Disproportionation equations, typically you're going to see these with decomposition reactions where it's the molecule that is interacting with molecules of its own that is going to cause the decomposition to actually occur. So when you're actually writing out your half reactions, you're going to go ahead and write out two separate ones. So one will be this Br2 transforming into Br1 minus, and then the second one will be Br2 transforming into that BrO3 1 minus. Now, in these examples, I just am having you guys do them in acidic solution. You could easily do these in basic solution by adding in those extra steps, but our answer key will reflect what would happen in an acid. So you start off by writing out Br2, and we're going to just kind of tackle that Br1 minus first. And the first thing we'll have to do is put a 2 in front of the Br because we had two bromines right here. And then the next step is, even though this is in acidic solution, there are no oxygens that we need to balance out. And so we're not going to have to introduce hydrogen ions to this part of the equation. So now we'll just balance out the charge. We have a 0 here and a -2 here. So I'm going to go ahead and add in the 2 electrons to the reactant side, and that takes care of our first equation. So my second equation, I'm going to go ahead and write out Br2 again. And now I'm going to look at the BrO3 1 minus. Similar to what we had to do before, because there are 2 bromines there and only 1 here, we are going to have to put a 2 in front of the BrO3, which now gives us a total of 2 times 3, 6 oxygens on that side. This is something we didn't have in the previous example. So we'll have to go ahead and put in 6 waters. And this is where those hydrogen ions are going to come into play. So now we have 6 times 2, or 12. And we'll add those 12 hydrogen ions on the opposite side. And looking at balancing, we've got a 0 plus a 0 equals 0. And we have a 2 times a -1, so -2, plus 12 times +1, so 12. And that gives us a +10. So we're going to have to add in 10 electrons to this side. All right, so I'm going to clean this up just a little bit and then go ahead and do the rest of this problem. So one of the things at this point I kind of like to do, especially with notability, is kind of slide things around to make it easier, line things up. So here we can see that we have 2 electrons on the top equation and 10 on the bottom equation. So just like before, we're going to go ahead and multiply that top equation by a number that'll get us to 10. So we're going to go ahead and multiply by 5. So we'll end up with 10 electrons here, 5 Br2, and then we'll have 10 Br1 minus, and then we'll go ahead and cancel out the things that are the same on both sides. So we'll have 10 electrons and 10 electrons, and then we can go ahead and finalize our answer by just writing out what is left over. So we have 6 waters, and we'll put a liquid symbol on that, plus Br2 gas, oops, should be Br2. Now when I'm looking at how many of them I have, this is a situation where we're going to have to add things together, because normally if they're on the opposite side, we can cancel them out. But if they're on the same side of the equation, we actually have to add them together. And we actually have 5 plus 1. So we have 6 bromines. So go ahead and put that there. And then that's going to lead us to having 10 Br1 minus plus 2 BrO3 1 minus plus 12 H positives. And this will be aqueous, this will be aqueous, and this will be aqueous. I'll go back here and put the gas on the bromine. Now, something to note is that it is quite likely that there was either a mistake made, or this was just a situation where we can actually simplify at the very end, because all of our numbers are divisible by 2. So we could go through and instead of having 6 waters, we'll have 3. Instead of 6 Br2s, we have 3. Instead of 10 Br1 minuses, we have 5. And we have 1 BrO3. And then we have 6 H positive. So in situations where at the very end, all of the coefficients can be simplified, that is what you need to do to finalize your answer.